In this video, we're going to continue with some examples of derivatives that we've seen in previous courses. We've added two extra formulas to our list over here. Same formula, basically. This is the chain rule. So if we have a composite function, we need to take the derivative of the outside function first and multiply it by the derivative of the inside function. So the derivative of f multiplied by the derivative of g. Typically, right now, we only see that in this form, which is the general power rule. So the n comes down, subtracts 1, just like we do here. But since this is a function here, we then need to multiply by the derivative of the function. In this case, y can be thought of as f of x, or a function of x. So when we take the derivative of y, we need dy by dx, or y prime. There's two ways to do this question. We can do it using implicit differentiation. So implicit differentiation, that means x's and y's are mixed together, like it's written here. To do this, we just take the derivative of each piece using the appropriate rule. So the derivative of x is 1. The derivative of y is y prime. And the derivative of 2 is 0. Since we want the derivative, we want y prime, we need to solve for that. That gives us negative 1. Now in this example, we could also do this explicitly. So explicit. And what that means is solving for y first. So in other words, writing y equals 2 minus x. Implicit, x's and y's are mixed together. Explicit, y is alone, all the x's are on the other side. So now the derivative is derivative of 2, which is 0. Derivative of x is 1, so 0 minus 1 is negative 1. So same in both cases. Implicit, x's and y's are mixed together. Explicit, solved for y explicitly, meaning all the x's are somewhere else or on the other side. This example, we're going to solve implicitly because the x's and y's are together and mixed up. The derivative of y squared, now remember, y is a function of x, so we're going to use this rule. The 2 comes down, the y stays the same, f of x doesn't change. 2 minus 1 is 1, so that's there. Multiplied by the derivative of this part, or the function, which in this case, the derivative of y is y prime. Plus, now this is just x here, so really now we're using this rule and this rule. This is 4x. The derivative of 5 is 0. Since we're looking for the derivative, we need to solve for y prime. We'll do it in 2 steps, just to see everything here. Negative 4x moves over. Here it's positive, here it's negative. Divide by 2y. Negative 4x over 2y. And of course the 4 and the 2 can cancel, leaving negative 2x over y. Next example, we're looking for higher derivatives here. Higher derivatives means that we can keep taking the derivative until we get to 0. Usually we ask for higher derivatives for polynomial type functions. So the first derivative, 15x squared minus 2, 5 multiplied by the 3 that comes down, again these two rules, minus the derivative of 2x, which is minus 2. This is also a function, so we can take the derivative again. 30x minus 0, the derivative of 2 is 0. Third derivative, 30. And fourth derivative, 0. And that's what we mean by higher order, or higher derivatives. Find all the derivatives until you get to 0. There's no sense in continuing because every derivative after that would be 0. In this example, we're also asked to find the higher derivatives. Special note here, this is a product. We haven't added the product rule to our list here, although you would have seen it before. So you could do this with the product rule. Usually it would be a bit more work. Easier if we can simplify first. So to simplify first, we expand this bracket, square the first term, the product of 2 times the first term times the second term, and square the last term. So that's that bracket expanded. And we multiply everything by x, then we get x to the 5 minus 2x cubed plus x. All we've done is simplify it, and now we're going to take the derivative. So first derivative, 5x to the 4 minus 6x squared, 3 times 2, plus 1. Second derivative, we just continue taking derivatives. So that's going to be 20, 5 times 4, x to the 3 minus 12, 6 times 2, x. Third derivative, we're going to do 20 times 3, which is 60, and the 3 becomes a 2. We're just using the same rules over and over again. Derivative of minus 12x is minus 12. Fourth derivative is going to be 60 times 2, which is 120, x to the power of 1 minus 0. Fifth derivative is going to be 120. And finally, the sixth derivative is going to be 0. Interesting note, we started taking the derivative, our polynomial had degree 5, or the highest power was 5. Took 6 derivatives to get to 0. If you look back at our previous example, we started with degree 3, took 4 derivatives to get to 0. So that's something that you can use to kind of make sure you're on the right track when you're doing these.